Now let's start with what vectors are. What do you remember about vectors? What comes to your mind? Something like arrow, okay? Can you not?
Something that looks like natural.
Looks like matrix. It's like a column vector. Matrix, okay? Any other thing?
Magnitude and direction.
Magnitude and direction. Vectors are quantities that has both magnitude and direction. And the magnitude of the vector, as we'll see, is the length of the vector. Okay? So let's write quantities. Actually, this is like physics definition. You don't need all that. I'm just going to go into the math after this. Quantities with both magnitude let's say quantity, whatever, and direction. We can pluralize everything. F. We represent them in different ways. The arrow that someone was talking about. So if I say on my xy plane, my vector from this point to this point, if the coordinate of this point is 2, 3, okay, it means the length of this, the distance from here to here is 2, right? And the distance from here to here is 3, right? So if this vector, this is O and this is A, so I can write it as vector OA with arrow on it, okay, is 2I plus 3J, where this is my I component and J component. I can write it that way. Another way I could write it is something that is similar to what we always see. I just write here 2, 3. So this is how we represent vectors. I'm sure we had something like this in Form 1 and maybe Form 2, but it doesn't matter. So you will be seeing things like this a lot. So for example, again, this is my vector OA from the origin to this position, that is 2, 3, for example. It means on the I component, this position is at 2 units, and the J component, just like X and Y axis. Alright? And the J component is 3, okay? So we can write it as 2I plus 3J, or you can put it in matrix form, like Anson said. But nobody is asking you to write a vector in what form. I'm just explaining what this symbol means. Okay? Now, instead of doing this, if this vector is A, small a for example, you will see it in bold prints. Sometimes some people underline it. So if I'm writing in class, I'm going to underline it. But in your question paper, it will be in bold print, just like Ctrl B on your Microsoft Word. So this is still the same 2 by 2, 3, not 2 over 3. This could be written as this. Okay? So 3 ways you can write a vector. You can use the endpoints to represent it. You can use the name itself that will be assigned to it in the question. And this is what this means. So this is just notations. You don't need to worry too much. Well, from the question I've given you, please look at the first page. Can you see OR equals to R?
Yes.
So they are telling you the vector that represents from that point to that point is vector R, basically. It's called R. So R could be MI plus MJ, for example. Do you understand my point? So these are just notations. Okay? And this arrow tells you where, from where to where. So you do not write it as OAO. No, they are not the same. So let's say, notes, OA is not the same as this. It's not the same. But, who can tell me the connection between OA and AO? It's just the reverse, right? So because of that, your OA is just the opposite of AO. Can you see that? Negation. Okay? The negation, the opposite, the reverse of it. Remember we said vector has magnitude and direction. This negative is telling you the direction is opposite of the direction of this. But of course they share the same length. The length of the vector is the next thing I will talk about before we start using vector algebra. So don't look at this paper yet. Okay? I will advise you not to look at the papers yet. Looking at it, you might be confused and you might think, oh my God, what is this? Let's understand this first. Now, okay, how about I give you this? I want you to write, this is vector 2i and 3j, right? So I give you this xy plane. This point A is maybe 2, 5. And this point B is maybe 5, 9. Can you write this vector R in terms of this? Write it in terms of this and in terms of this. Vector AB is what? AB or AB in matrix form. Try to complete that. Just sit up, sit up, sit up, sit up. Try to complete that. I was going to ask you to sit up. If you have some answer, raise your hand. Have you written it in your book? Good, that's it. One answer right. Listen. Yes. Two answers right. Perfect. Where is it? Yeah, correct. Correct. So, the ones I've seen so far are correct. What I will just do, if this is my first time, is to check this. Because the idea that I mentioned here is to look at the distance along the horizontal and vertical, right? So check the distance between A and B along the horizontal and check the distance along the vertical. So, if you want to go more details, this is x is 5, for example. I'm looking at it as xy axis now. And this is 2. So what is this distance? 3. Right? And in this case, what is y here? And what is y here? So what is this one?
4.
So which means along the horizontal is 3, along the vertical. So the horizontal component is the I component and this is the j component. Okay? So what would that be? 3i plus 4j. And if you put it in this form, just 3, 4. Does that make sense? You understand? Yes? Yeah, I understand. Okay, great. Okay, so let's move on from here because these are just basics. Any question, please? Because I don't want somebody to get emotional. They want me. Truly want me. If I start getting emotional, it's because the last time I did vectors, I cried.
So it's different from...
I'm trying not to make her emotional this time.
So it's different...
You're control. Okay, thank you for controlling. She's controlling herself. So we are still safe.
So it is different from Pythagoras.
What do you mean?
It's different from Pythagoras.
What do you mean Pythagoras?
Why is it related?
This has nothing to do with so far. It's not nothing to do with Pythagoras. Okay, so let's move to magnitude. Let's review magnitude. What is the other name for magnitude? Value, yes.
I'm sorry.
I'm sorry. Is that one of them? Magnitude.
Wow, physics.
Magnitude means length, for example. Okay? The length of a vector. So when we say length of a vector, we are talking about, for example, distance between A and B. And that's when Pythagoras theorem comes in. That's why I said so far we have nothing to do with Pythagoras theorem. So I don't know why you got that from. So with this, how do we find the length of a vector? So let's go again to our xy plane. So let's assume we have this vector, vector r. Okay. If we can get the x and y components, so this is the x, I and j component as x and y, for example. I don't know what they are. They could be this 4 and 3 that we got by subtracting, and they could just be 2 and 3 that we got just from the origin. So I just call them x and y. So we don't know where the origin is, we don't care. Do you understand my point? So the length of this vector is actually this, the length from here. So if this is maybe O, not necessarily O, let's say P, and let's say Q. So the magnitude of this vector R, so write please quickly, the magnitude of PQ, which is R, so I underline it because I can't write bold print on the board. Okay? But usually it's bold print. The magnitude of that denoted by, so we just use that, that's how you denote it. You put 2 like absolute value. Okay? It's denoted by this, which is in this case the same as this. Okay? Will be so when you use Pythagoras theorem, PQ squared will be x squared plus y squared. Am I right? So if you want to get the magnitude itself, all you have to do is the square root of sum of the squares. That will give you the length of the vector. So even if the vector is QP, does it really change the magnitude? No. No. Because no matter your direction, whether you go up or down, it's still the same length PQ, right? So it doesn't matter. And we can see that clearly. If you claim that your y is now minus y and your x is now minus x, does it matter when you square them? No, it doesn't. So you still get the same magnitude. So vectors in opposite direction can have different direction, which is denoted with the negative sign, but the magnitude remains the same. So I'm going to put some vectors here, and I need you to find their magnitude. For example, we start from this. Find the magnitude. We're going to do this. Find the magnitude of the following. So the first question, AB that you got earlier, 3I plus 4J. Can somebody tell me what is wrong with this symbol, if anything?
The absolute value.
The absolute value, why?
Because 3i plus 4j is not the Pythagoras.
It's not what? You're on the right track. It's not what?
It's the absolute value.
It's not. What
It's a
should
real
I?
number.
It's not what?
Real number.
It's not a real number. Because this will give you a real number. So the magnitude is always a real number. So maybe I put here, it's got to the length, always a scalar. Scalar means a real number. Okay? So this is not a scalar. So there's no way this symbol should be there. So it doesn't make sense. Once you have that symbol, it should be equal to a number. 5, square root of 2, 2.4, fraction, and so on like that. Please sit up, sit up, sit up. This is a class, not a sleeping room. I don't know what you did to yourself over the break. During the break I mean, but don't bring it to my class. So let's solve that. Let's find the magnitude. If your magnitude is going to be a decimal, leave it as significant figure or in square root form. Yes, what is it?
Good answer. How, yeah, that way can work.
What? Okay. There are 3 questions on the board. I do not expect anyone to be idle right now. So far, I'm going to ask you to do some questions from the worksheet. Okay, so far I should be able to do this from the past questions I just gave you. So, once you finish up to question 2, go to your worksheet and attempt those problems.
I'm not sure we can force this thing.
You have to separate it into 2 guys.
We will do that. Because there's no point leaving it on the board.
Yeah, they will do it.
Yeah.